Hello everyone, this is Dr. T. Bhargava Ramu, Assistant Professor, EEE, MLR Institute of Technology, Hyderabad. So in previous videos, we were discussed regarding underground cable classification and parameters related to underground cables and grading of the cables also. So in today's discussion, we will discuss about capacitance of 3-core belted cable. So this is one of the parameter associates with underground cables. So in today's content, we are discussing regarding capacitance of 3-core cable, and in this capacitance calculation, we need to measure the two quantities, one is CE and CC quantities. So we will discuss related to what is CE and what is CC. So two types of capacitance values we need to calculate. So first we will enter into the capacitance of 3-core cable. So in 3-core cable, different types of capacitances will exist. So this is because of the conductors are nearer to each other and to the earthed sheath. That means if you see this figure, so if you see any underground cable like this, so these within this underground cable, so cables are placed nearby each other. So due to this effect, so in between these two conductors, this is one conductor, this is one more conductor, and this is one more conductor. So between three conductors, so capacitance will exist, and distance between the conductors is very less. And moreover, this conductor and the sheath, outer surface of the conductor, so this distance is also very less. Due to this less distances, capacitance may exist within the underground cable. So in case of single core cable, so we cannot expect much because only one conductor will be present within the cable. So only one type of capacitance will exist. But in the case of 3-core cable, so we have 3 cores within the cable. So between the core to core, capacitance will exist, and core to sheath also capacitance will exist. So they are separated by a dielectric of permittivity much greater than the air. So if you see, in case of overhead transmission lines, so the air will be the medium between the conductor to conductor. So this is, if you say this is a phase A and this is phase B, between phase A and B, air will be the dielectric medium within the two conductors. So rather than this air in the underground cable, so there exists high permittivity, greater permittivity material within this conductor, within this sheath and conductor. So due to this, capacitance may play additional role. We need to consider the capacitance value, but in case of overhead transmission line, resistance and inductance will be considerable values, and capacitance value will be very less. But in case of underground cables, capacitance value will be more. Next, so potential difference exists between pair of conductors and between the earthed conductor and the sheath. That means, so the potential difference exists as we seen in previous figure. So there exists potential difference between conductor to conductor, in between these two, and in between these two also. Earthed sheath and the conductor, and conductor to conductor, potential difference exists between these two items. So due to this, electrostatic field are set up within the cable. Due to this voltage difference, electrostatic field will set up within the cable. So these electrostatic fields will give rise to capacitance within the cable. So we can say core to core capacitance as we can represent as C suffix C. Core to core capacitance we can represent as C suffix C, and core to earth capacitance, So earthing means the sheath is connected to earth, it is grounded, and outer sheath is connected to grounded. So we can say between conductor to sheath, this we can say it as core to earth capacitance, this is CE. And between conductor to conductor we can say it as CC. Conductor to conductor we can say it as CC, and conductor to earth we can say it as CE. So this is shown in figure. So we can represent all these capacitances with capacitors which are connected between conductor to conductor CC and core to sheath. It is represented in this diagram. Coming to the three CC are delta connected. If you see in previous figure, so core to core capacitors, these are the core to core capacitors. If you consider the cores like this, in between core to core, if you represent capacitances, so these three capacitances forms a delta connection. These three capacitances forms a delta connections. All these three CCs, C suffix C's forms a delta connection. And core to earth forms star connection. Core to earth forms star connection. How it is? This outer sheath is we can say it as a single node. Outer sheath we can say it as a single node. So it is represented as a star point. That outer sheath is converted into star point, and between star and conductors, this is one conductor core, and this is one conductor core, and this is one more conductor core. So these three are connected in star connection. We can say CCs are connected in delta model, and we can represent Cs are connected in star model. Cs are connected in star model. Sheath is converted into a star point. As we said, sheath is converted into a star point. The equivalent circuit looks like this. If you represent all CCs and Cs, we can say this is conductor A and conductor B and conductor C, and this is the sheath point. Sheath point is converted as a single node, that is as a star point. So this is the equivalent circuit of the 3-core belted cable which represents capacitance along with capacitances. Now if you convert the delta, the CC's delta which are placed within the conductor, within the underground cable, so this ABC, we can say it as ABC. So this delta system is converted to equivalent star. When you convert into delta to star, the capacitance value becomes 3 times. The equivalent value of capacitor in star system becomes 3 times of the delta value. So we are replacing this delta. Into a star model. That means we have two stars. Previously with Cs and newly with 3cc. Now we can convert this. We can redraw the circuit like this, equivalent circuit. So these are these 3 stars, 3 values of CCs, C equivalents. This one and this one are represented here, and CE also represented here. That means we have 2 star connections. One is convert delta to star converted, and originally star is there. So these 2 star connections are overlapped. So then these 2 values becomes parallel. These 2 capacitances becomes parallel. So if you make a parallel value of this equivalent value, then this becomes CE plus 3cc. So this diagram represents equivalent circuit of capacitance in case of 3-core belted cable. Equivalent value of capacitance in case of 3-core belted cable. So from this, if V phase is the phase value and capacitive reactance per phase is given, we know, if you know these 2 values, we can calculate leakage current of the 3-phase underground cable. And per phase, IC value is per phase leakage current. Next, coming to, so how to calculate the CE and CC values. This is one more thing we need to develop, how to know the CE and CC values. So for calculation of CE and CC values, we have to perform two measurements. On the underground cable. That is, so one performance is 3 cores are bunched together. That means, so if you take a cable, within that 3 conductors are there. We have to bunch these 3 cables, A, B, C conductors. We have to short circuit. It means bunching means short circuiting 3 conductors. So this is one performance we have to make it. Then we have to calculate something. And 2 cores are bunched with the sheath. That means 2 cores are bunched with sheath means these are the 3 cores, okay, and we have a sheath like this. So this and this, these two are connected to the sheath. These two conductors are connected to sheath. That means indirectly these two are shorted, and in turn it is shorted with the sheath, outer surface of the underground cable. So these two things we have to make it, then we will be able to calculate C and CC values. C and CC values. So the two performances are 3 cores are bunched together and 2 cores are bunched with the sheath. 2 cores are bunched with the sheath. So if we consider first case like this, if we consider first case, so this is the sheath. So within this, so these 3 cores are bunched together. So in this case, the equivalent capacitance, the resultant capacitance is measured between one conductor to the sheath. The capacitance measured between the bunched cores and the sheath. Bunched cores and the sheath. So this value will represent with as C1. In this performance, in this measurement, we will call that equivalent capacitance value, the resultant capacitance value as C1, that is measured between sheath and the conductor, one conductor, any one of the conductor. So we short circuited all these 3. We can say it is across capacitance across sheath and any one of the conductor, and that value becomes, if you draw the equivalent circuit for this, it becomes like this. It becomes like this. Equivalent circuit for this. So these 3 are the ABC conductors and this is the sheath. The equivalent value becomes 3 times of CE. 3 times of CE. This is CE and it is also CE. So 3 CEs in parallel becomes 3 times of CE. So that 3 times of CE is represented as C1, 3 times of CE. So this is one conclusion we got from this measurement. And if you move on to this next type of measurement, next kind of measurement, so when 2 cores are bunched with the sheath, so it is represented here. So one is like this, 2 cores, this is B and let it be C, and 2 cores are bunched and connected with the sheath. So the other conductor is as it is, So between these other 2 conductors, the capacitance will exist. That means in this case, one CE will be present, 2 CCs will be present. One CE will be present, 2 CCs will be present. So this is the diagram for the second measurement calculation. In between, capacitances will exist and the conductor is as it is. So the equivalent circuit can be drawn like this. Of this measurement. So 2 CCs will be in parallel and in parallel with the 1 CS. So resultant value we will measure between, between that and the third core. Capacitance is measured between them and the third core. That means this value will take C2, it is represented as C2. The C2 equivalent value becomes 2 times of CC and CE. So by this equation 1 we have seen, this is one conclusion we got, that is C1 equal 3 CE, and this is second conclusion we got, C2 equal 2 CC plus CE. So by using these two equations, we can calculate CC and CE values from these relations. So these two performances are needed to calculate the conductor to conductor capacitance and conductor to sheath capacitance. So by knowing these two values, we can calculate total equivalent capacitance of the 3-core belted cable, that is given by CS plus 3CC. By substituting CS and CC values, we can calculate total net capacitance of a 3-core bunched cable. So with this, in this topic we discussed regarding how capacitance will exist in 3-core cable and the equivalent circuit of capacitance when we consider capacitance between core and core and between core and sheath, and after that there are two types of capacitance values will exist. So how to measure these two values C and CC? We performed two experiments. One is short circuiting three conductors is one kind to calculate one value of capacitance, equivalent value, and short circuiting of two cables, two conductors with the sheath, that is one more performance. We calculated equivalent value of capacitance C2. By using this C1 and C2, we can manipulate the values, and at last we will calculate C and CC. So thank you. This is regarding underground cables capacitance when consider a 3-core belted cable. Thank you very much.